Hi everyone! In this series of videos we're actually going to start something new in lesson 8H called recursive notation. This is going to be something that we'll gradually try to build over the series of a few pages in the packet. So this series of videos for this particular playlist is just going to help give you some of the foundations, and then on page 15 we'll build on those foundations. That'll be a separate playlist, and then next week when we get to week 34 we'll really start to kind of tie the ideas together. So this is definitely a slow building concept. It's a concept that takes a lot of time to develop because it is so new, and it's very dependent on what we call notation. Notation is the way we write something. So this is going to be all about writing formulas in a very strategic way that might be new to some of us. And because it's new, I do recommend that you take this gradual approach and work page by page through the packet rather than to try to skip or to try to do a whole bunch of pages at once. That's obviously your decision to make, but my recommendation is to try to take it a little slowly just so you can let the idea build, especially if this is brand new information. In question number 1, we're actually going to start with a famous sequence, a sequence that some of you may be familiar with, or if you did the Free Play Friday way back in the day, week 30, I think it was, there was a sequence that we explored called the Fibonacci sequence. It's an important sequence in lots of different real-life aspects, which we won't go into too much in these particular videos, but again, if you want to explore the Fibonacci sequence and its real-life implications, you can go back to the Free Play Friday in week 30, and that will give you a whole bunch of links that you can explore if you're interested. Now, the key with the Fibonacci sequence is understanding that the pattern itself is a little bit hard to see. If you take a look at the numbers, you probably will notice that the table is set up the same way that most tables are, where n just tells you what term number you're in the sequence. So I'll call n the term number. But t of n is the actual important information. T of n is the actual term itself. So the 0 term, or the initial value, is 0. The first term is 1, the second term is 1, the third term is 2, the fourth term is 3, the fifth term is 5, the sixth term is 8, and the seventh term is 13. So the terms in the sequence are actually the t of n numbers. Those are the numbers I'm going to kind of underline. Those are the important numbers. Now the first question in letter A asks us, is this arithmetic, geometric, or neither? So let's see if we see the pattern. If you haven't yet, I'm going to give you some time to really stare at those underlined numbers. Do you see a pattern to them? Because there is a pattern. It's an interesting pattern because it's not the same way that we've ever done patterns before, but here's the pattern if you haven't seen it. If you take 0 plus 1, the initial value plus the first term, you'll get 1, which is the next term. If you take 1 plus 1, you'll get 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. So the pattern doesn't have a consistent adder. The number that you're adding changes for each part because you're not adding one number over and over and over and over again. You're adding different numbers depending on where you are in the sequence. The fifth and the sixth terms, the 5 and the 8, have a different pattern to them than, say, the 1 and the 2. So to answer question letter A, we should probably say that it's neither arithmetic nor geometric. It's not arithmetic because you're not adding the same number each time, and it's not geometric because you're not multiplying at all. So you can pause and put that answer into your own words, but that's generally why it's not either arithmetic or geometric. It's because you're not adding a consistent value each time, there's no adder, and you're definitely not multiplying, so there's no multiplier either. Now in question letter B it says, explain how to find the 8th term in the sequence. Well, conveniently, the 8th term is the next term in the table. So let's just think logically for a second. If I continued my table to the 8th term, how would we get that? Well, so far it seems to get any number in the table, add the 2 terms that came before it. So if I'm here at the 8th term, I need to focus on the 2 terms that came before it. So 8 and 13 must combine together to give me the next term. 8 plus 13 would be 21. So if you want to articulate that in your answer, you can obviously say that the answer to the 8th term is 21, but specifically the question says explain how to find the 8th term. You would find the 8th term by adding the 6th and the 7th terms together. So technically we added the 8 and the 13, but we were calling them the 6th and the 7th terms. In question letter C, it says explain how to find the 9th term. Challenge yourself to do that, because it looks like the 9th term is simply the next part of the table, the next number in the sequence, and it looks like if the pattern continues that I would simply take the 2 terms that came before it. So I would take the 13 and the 21. 13 and 21 adds up to 34. And I could keep doing this pattern as long as I want to. It just looks like all you have to do to get another term is to add the 2 terms that came before it. So again, I'll articulate here how to find the 9th term. It looks like we added the 7th and the 8th terms. So now that we're thinking logically, hopefully you can see why it's not possible for us to have an equation for this thing. We know what to do, but an equation seems unnecessary. And it's because we don't really have enough information to fill either of the equation structures we know. Remember how in letter A we said it's not arithmetic or geometric? Well, those are the only 2 things we know. The equations that we've always dealt with are arithmetic or geometric. And I can't write an equation because I don't have some of this information. I can't write an arithmetic equation because I don't have an adder. The adder's not one single number. I can't write a geometric equation because I don't have a multiplier. It's not multiplying at all. So the answer to letter A and the answer to letter D are very similar. It's impossible because it doesn't have the structure of an arithmetic or a geometric sequence. So as we're thinking about this sequence then, make sure it makes sense to you that this is not arithmetic. Make sure that it makes sense to you that it's not geometric. Make sure that it makes sense where the numbers in the sequence come from. Because in the next video, we're going to talk about the kind of equation it does have. It doesn't have a traditional looking equation, but it does have an equation. And it's an interesting equation to look at. So in the next video, we'll talk about what that equation really is.